Hello everyone, welcome back to my YouTube channel. I am Kavya. Currently, I am pursuing MBA first sem in Sri Venkateshwara Engineering College, Bangalore. Today, I am going to explain about the understanding measures of variability of range, variance, and standard deviation. Understanding measures of variability. Measures of variability are statistical tool used to quantify the spread or dispersion of dataset. Understanding these measures is crucial for interpreting and analyzing data effectively. In this presentation, we will explore three key features of variability of range, variance, and standard deviation. This concept will provide you deeper understanding of distribution and spread of data. The real life variability. Some degree of variation is unavoidable. However, too much inconsistency can cause problems. If your morning commute takes much longer than the mean travel time, you will be late for work. If the restaurant dish is much different than how it is usually, you might not like it at all. And if a manufactured part is too much out of specific, it won't function as intended. First, let us know about the range because it is easy to understand. Range is the simplest measure of variability, representing the difference between highest and the lowest value in a dataset. The range gives you quick understanding of overall spread of data, indicating the maximum and minimum values. It can be useful starting point for analyzing data distributions. The range is sensitive to outliers and extreme values and provide an incomplete picture of data's variability. Calculating range. Identify the highest and the lowest value in the dataset. Subtract the lowest value from the highest value to get range. Range is a single number that represents the overall spread of the data. For example, if the value in the dataset are 5, 12, 8, 10, 3, in this lowest value is 3 and the highest value is 12. So we have to subtract lowest value from highest value. Highest value is 12 and the lowest value is 3. 12 minus 3 is equal to 9. The range is 9. What is variance? Variance is the measure of the average square deviation from the mean of the dataset. It quantifies the spread of the data by considering the distance of each data point from the mean. Variance provides a more comprehensive understanding of variability compared to range, as it takes into account the distance of all data points from the mean. Higher variance indicates greater spread of the data. Variance is sensitive to outliers and can be influenced by extreme values. It also has a different unit of measurement than the original data, making it less intuitive to interpret. Calculating variance. Calculate the mean of the dataset. For each data point, subtract the mean and square the result. Add up all the square deviation and divide by the number of data point to get the variance. There are population variance and simple population variance. The formula for the variance of an entire population is the following. Sigma square is equal to summation x minus m whole square divided by n. In the equation, sigma square is the population parameter for the variance, m is the parameter for the population mean, and the n is the number of data point which should include the entire population. Simple variance. To use a simple to estimate the variance for the population, use the following formula. Using the previous equation with the sample data tends to underestimate the variability because it's usually impossible to measure an entire population. Statisticians use the equation for simple variance much more frequently. S square is equal to summation x minus m whole square divided by n minus 1. In the equation, S square is the sample variance and the m is the simple mean. N minus 1 is the denominator, corrects for the tendency of a sample to understand the population variance. Example of calculating the sample variance. I will work through an example using the formula for the sample on the dataset with 17 observation. The number in parentheses represent the corresponding column number. The procedure involves taking each observation 1. The subtracting the sample mean 2. To calculate the difference is 3. Squaring the difference is 4. Then sum the square difference at the bottom of the table. Finally, I take the sum and divide by 16 because I am using sample variance equation with 17 observation. 17 minus 1 is 16. The variance for the data set is 201. Let us solve the problem. Data point is 11, 16, 19, 20, 21, 22, 25, 26, 29, 33, 34, 38, 39, 46, 52, 55, 58. The mean is 32, 32, 32, 32. Difference is the data point and the mean difference is 21, 16, 13, 12, 11, 10, 7, 6, 3, 1, 2, 6, 7, 14, 20, 23, 26. The square difference. That means a difference square like 21 into 21, 16 into 16, 13 into 13. The square difference is 441, 256, 169, 144, 121, 149, 36 9 1 4 36 49 196 400 529 676. The total or sum is 3216, that is divided by 16 is equal to 201. The variance is 201 because the calculation used the square differences. The variance in the squared units rather the original unit of the data, while higher values of the variance indicate greater variability. There is no intuitive interpretation for specific values. What is standard deviation? Standard deviation is the square root of variance. It represents the average distance of data point from the mean. It provides more tentative measure of variability compared to variance. Standard deviation gives you sense of how much a typical data point deviates from the mean. It widely used to access the spread and distribution of dataset, with larger standard deviations indicating greater variability. Standard deviation is the same unit of measurement as the original data, making it easier to interpret and compare across different datasets or variables. Calculating standard deviation. Calculate the variance of the dataset using the formula from the previous section. Take the square root of variance, get the standard deviation. Standard deviation is the single number that represents the average deviation of data point from the mean. For example, if the value of the datasets are 5, 12, 8, 10 and 3, the standard deviation would be square root of 12.96, which is approximately 3.60. Standard deviation is the standard or typical difference between each data point and the mean. When the values in the dataset are grouped closer together, you have a smaller standard deviation. On the other hand, when the values are spread out more, the standard deviation is larger because the standard distance is greater. Conveniently, the standard deviation uses the original unit of the data, which makes interpretation easier. Consequently, the standard deviation is the most widely used measure of variability. For example, in the pizza delivery example, the standard deviation of 5 indicates the typical delivery time is plus or minus 5 minutes from the mean. It's often reporting along with the mean 20 minutes. Standard deviation 5. Standard deviation is just the square root of the variance. Recall that the variance is the squared units. Hence, the square root returns the value to the natural units. The symbol for the standard deviation as the population parameter is sigma, while S represent it as a sample estimate. Interpreting measures of variability. Range. The range is the simple and the straightforward measure that provides a quick understanding of the overall spread of the dataset. However, it is sensitive to outliers and does not consider the distribution of the data points. Variance. Variance is the more comprehensive measure that takes into account the distance of all data points from the mean. It provides a quantitative assessment of the spread, but the unit can be less tentative to interpret. Standard deviation is a widely used measure that represents the average distance of data point from the mean. It is in the same unit of measurement as the original data, making it easier to interpret and compare across different data sets. By understanding these three measures of variability, you can gain valuable insights into the distribution and spread of your data, enabling you to make more informed decisions and draw meaningful conclusions from your analysis. Thank you for watching. If there are any opinion regarding my YouTube video, comment me in the comment section. If you like my video, do like, comment and subscribe my YouTube channel. Thank you for watching.